This is it. Perhaps one of the most important chapters or sections of this chapter, because this will lead us straight to writing chemical formulas. And AC knows how important that is. Very, very important. So 55, what are atoms made up of? Again, protons and electrons. Now, what about neutrons, Mr. Moreno? We've talked about neutrons. Yes, they are made up of neutrons, but when it comes to the way they act, the way they react, neutrons are really not that important. The most important thing that we remember about neutrons is that they're in the nucleus and they help keep the protons glued together in the nucleus. They are the buffer zone between protons because we know that positives don't like other positives. So they're the peacemakers inside the neutrons. All right? When we say that an atom is neutral, what do we mean? They have equal number of protons and electrons. Therefore, neutral. You have 5 positives, you have 5 negatives. 5 positive plus 5 negative is 0. But alas, that's not always the case. When we were doing the nuclear symbols, remember? We know that sometimes they can be positive or negative. When an atom loses or gains electrons, it is no longer called an atom. It is called an ion. So when I had my first kid, his name is Adam. Kids asked me, what's his name? I said, Adam. And they said, atom? Like an atom? And I thought to myself, yeah, right, like an atom. So being the person that I am, I said, yes, like an atom. And they just don't, they figured I'm a chemistry teacher. I'm going to name my child Atom. So when my second child came around, I called him Ion. They accepted it. Atom and ion. No. An ion is an atom that has lost or gained electrons. Well, what do we call it if we lose or gain protons? Nothing. That's not possible. You can't lose or gain protons. Okay? You cannot. No, it's not all right. You cannot lose or gain protons. People think they can all the time. And you're going to sit there and go, all right, yeah, sure, I know. No, they will. You will think at some point, you will think that somehow you can lose or gain protons and you will be wrong. And then I'll remind you. Remember when you said, all right, it's okay. I said, all right. When they gain electrons, when they gain negative things, what happens to them? Well, they become negative. When you have more negatives than positives, you become a negative. Okay, we have a special name for you now. You are an anion, an anion, an anion. They have more negatives than positives. For example, nitrogen, 7 protons, 7 electrons. If it gains 3 electrons, will be nitrogen -3. Why? Because it'll have 7 protons and 10 electrons. 10 electrons. That means the negatives are winning by 3, right? Right. Now, how do I remember this? Well, anion kind of reminds me of an onion. And onions have these stripes where the layers are, kind of like Shrek, right? So if you think of the layers as being negatives, then an onion will remind you that anions are negatives. So when they lose electrons, they lose people from the negative side. They lose people from the negative side. what happens to their charge? They become positive. Because now you have more positives than negatives. An example, yes, pass that back. An example of this, sodium, 11 protons, 11 negatives. What happens if they lose an electron? 11 positives, 10 negatives, which means positive 1. Positive 1. One of these up.
Surely we'll be back to this on the guys.
Okay. So they will have more positives than negatives. They will have more positives than negatives. That's why sodium is positive 1. They will have more positives than negatives. Notes. There is no difference between the name for the positive ion and its ion version. But the negative ion will have its name changed to IDE. The way I like to think of this is traditionally, back 50 years ago, if cations, oh, I think I forgot to tell you how to remember cations. Ow, a cation. So normally a name is made up of a cation and an anion. Traditionally, husband, wife, and traditionally, who got their name changed? The wife. So it's always the last, the negative ion, that gets the name changed to IDE. For example, chloride -1, chlorine -1 becomes chloride. Oxygen -2 becomes oxide. Nitrogen -3 becomes nitride. Yes. Yes. That's right. Okay, so if you're sodium and you lose an electron, you're just called sodium. You are sodium plus. You have lost an electron. You have lost an electron. If you are magnesium, you will lose 2 electrons. 2 electrons. So you are still called just magnesium, but notice you now have a positive 2 charge. If you're aluminum, you will lose 3 electrons. So you will have a +3 charge. Notice your name is not changed, Sierra. Your name is not changed. But if you're chlorine and you gain an electron, you are now called chloride. Chloride. So this is chlorine. This Cl negative is chloride. The difference? Chlorine will kill you. Chloride you have in your blood system. It's part of our diet. It's in our salt. You put it on your French fries. Because it's chloride. No, it's chloride. What do we know? How do we know whether a cation will lose 1 or 2 or 3 electrons, or whether an anion will gain 1 or 2 or 3? We look at our best friends. We look at our best friends. Best friends. What important piece of information can the periodic table easily tell us? Whether an element is a cation or an anion. How? Well, anything on the left of the zigzag line, positive. Anything on the right of the zigzag line, negative, an anion. So anything on the left of the zigzag line forms a cation. Anything on the right of the zigzag line forms an anion. We're on 64. It's that easy. Anything left, cation. Anything right, anion. Now, how can you tell about their charges? Well, group 1, the alkali and silver is always +1. Group 2, the alkaline, zinc and cadmium are always +2. Group 7, the halogens are always -1. Group 6, always -2, as long as they're on the right side of the zigzag line. Aluminum, gallium, thallium, +3. Now, how can you tell about their charges? Well, some ions can have more than one charge. Why? Can you guess? Anybody? Why is it that some ions can have more than one charge? They're wishy-washy. They don't know. Sometimes they're 1, sometimes they're 2, sometimes they're 2, sometimes they're 3. How can you tell? How can somebody tell you which charge to use? Easy. Roman numerals. For example, iron comes in 2 forms, iron 2 and iron 3. Iron 2 and iron 3.
Mr. Mayor, what was the last bullet point for 64?
Anions are on the right side of the zigzag line. It's at the end of the notes? Okay. All right. Take out a pencil. Take out a pencil. Take out your best friend. You need to tattoo these things on your best friend. First of all, go to the first column and put a +1. On top. So I'm circling everything that you should be putting down. Go to the top of the second column and put a +2. +2. The top of the 8th column, put a 0. Why? They don't react. They don't react. the top of the 7th column, put a -1. Top of the 6th column, the one beside -1 is -2. -2. Now that ends right here because that's where the zigzag line comes through. This column right here is -3, but it's only to the zigzag line. Yes. No. No. And then all of these, put them in. Yes, the line you can do darker. I don't want you to highlight anything else. Everything that you see. Huh, how come it's not highlighted? All right. I don't know why. Oh. No. Periodic table. Believe me when I tell you, if you do not put this information down, you are cooked. You are done.